order of magnitude. So yeah, we're looking at a very much ballpark figure. We tend to not ever get really specific. You would not say, if we look at that quiz from, of those answers, only one of them has a power of 10, or only two of them have powers of 10, and order of magnitude estimations always contain a power of 10. One of them is way too specific. 6.022 times 10 to the 23rd is far too specific to be an order of magnitude estimation. If we were making an order of, what is that number, by the way? You remember? It's the number of particles in a mole. It's Avogadro's number. Yeah, you knew it was connected to the mole somehow. If we were making an estimation of Avogadro's number, order of magnitude estimation, we could say 6 times 10 to the 23rd. So that would be a reasonable order of magnitude estimation for Avogadro's number. 10 to the 5th is an order of magnitude estimation. So it's very broad. That covers a lot of ground. That covers everything from, 10,000 up to 99,999, somewhere in there. I mean, that's 10 to the 5th. Those are all order of magnitude 10 to the 5th. We get a little bit more specific because of that. So let's look at, it's a little bit trickier. Which list of numbers below contains only one order of magnitude? The thing we need to do is basically get that down to one digit for each of those. So 27, 41, and 4. What order of magnitude is 27? 27 is order of magnitude 10 to the 1st. If we were going to do something that was a more specific order of magnitude on that, we could reasonably say 3 times 10 to the 1st. That's pretty specific for order of magnitude. That's pretty darn specific. Why 3 times 10 to the 1st? Because you look at your rounding rules for that first digit. You're never going to have more than one digit for an order of magnitude estimation. Okay, what about 41? Order of magnitude? Also 10 to the 1st. And if we were going to do a much more specific order of magnitude estimation on that, we could say 4 times 10 to the 1st, but we would still say those are within the same order of magnitude. They're still within the same order of magnitude. Okay, 4. What order of magnitude is 4? 10 to the 0. You have to be really careful with that. So, okay, and with anything that's in the order of magnitude 10 to the 0, we would never have anything beyond just 10 to the 0. It's such a small range anyway already, there's no need to clarify that further. I mean, 10 to the 0 covers less ground than any other order of magnitude there is. So, obviously that one's out. Let's look at the second one real quickly. So we have whoops, hold on. Okay, order of magnitude on the first one. Go ahead. The broad order of magnitude would be 10 to the 3rd. And if we were going to get at all specific, we could reasonably say 2 times 10 to the 3rd. We'd never get more specific than that. Second one, be careful. Yeah, that one's really going to be 10 to the 4th. Why? If you got it down to one digit, if you rounded that for significant figures to one digit, that's going to become 10,000, because that 9 would round up. So we would say 10 to the 4th for that. That one would be 10 to the 4th. And when it's a 1 times 10 to the 4th, we could say 1 times 10 to the 4th. These notes are horribly messy, I apologize. But very often we would just say 10 to the 4th. Okay, what about the last one? Solidly, straight up 10 to the 2nd, right? Dead in the middle of 10 to the 2nd. Yeah, 10 to the 2nd. So 10 to the 2nd, if we were going to get really specific about it, and remember, this is really specific for an order of magnitude estimation, 5 times 10 to the 2nd. was about the most specific we could get. So, with orders of magnitude estimation, we really only want to ever see one digit. That's all we can afford to estimate. Okay. So let's look at the options for that third answer, which Moser clearly admits I kind of screwed up there. So if we were looking at the broadest sense of order of magnitude estimation, as they stand with no rounding whatsoever, we could make an argument that these are all 10 to the fourth. However, if we're really honest about it, yeah, this one's 10 to the fourth, and this one's 10 to the fourth. That one's pretty clearly 10 to the fifth. Because if you got it down to a single digit, it would be 10 times 10 to the fourth. That's 10 to the fifth. So, no good answer. Sorry, folks. I gotta fire whoever writes these quizzes. Okay. So if we were going to get more specific, we could say 7 times 10 to the fourth, 8 times 10 to the fourth, obviously 10 times 10 to the fourth, or 10 to the fifth. Okay. So let me ask you, if we look at the fourth answer, we can tell right off, nowhere near same orders of magnitude. We'd have 4 to the first, 4 to the first, and 10 to the 0. So 4 times 10 to the first, 4 times 10 to the first, and 4, or just 10 to the 0. So obviously those are out. So yeah, C was what was supposed to be your answer, but the quiz writer did a terrible job. If only I had... Now, okay, let's look at those three options for C. Change one number and make that a correct answer. There are multiple ways to do it. Change one number in any way. Add it, delete it, just change it. Change one number and make that correct. Hold on. Okay, so if we change that second digit, then that would make the order of magnitude estimation on that 9 times 10 to the fourth. That would be same order of magnitude. What's another way to fix it? Okay, we could change the 9 to an 8, and then we've got 2 8 times 10 to the fourth. What else could we do? That was what I would have done. That would make it the trickiest. That's the sneakiest, trickiest, meanest way to do it. Because, yes, of course, that's what I'd pick. So yeah, because that would make it 10 to the third, which would make it 10 to the fourth. Make it 10 times 10 to the third, which would make it 10 to the fourth. That's mean and nasty and dirty pool as far as I'm concerned. So of course I love it. Next quiz. No, I don't want to stop. Okay, there we go. Which numbers are correctly paired with their order of magnitude? 75 and 10 to the third. Yay or nay? Pardon?
You missed the question.
Oh, okay.
You missed the one.
Which numbers are correctly paired with their order of magnitude? 75 and 10 to the third? No. 0.01 and 10 to the negative first? No. 999, this is one of those tricky ones. 999 and 10 to the third. Yeah, because that's pretty darn near 1,000. And the fourth one, which I just obliterated, not times 10 to the negative fourth at all. Okay. Let's actually, what is the order of magnitude of that number? Magnitude can be used to obtain precise numeric values? No, of course not. Quick estimations and checking answers, yes. And if we look at that last one, multiplying 318 by 271, order of magnitude estimation of the answer. Okay, so for that, we can do the more specific version, which probably serves us pretty well when we're actually looking for a ballpark for the answer. If we even doing the very broad general, we know that our answer should be somewhere in order of magnitude 10 to the fourth. So that's helpful, I think. Okay, so what would the diameter of the sun be in meters? Okay, so it would have to be more than 100 meters, more than 1,000 meters, more than 10,000 meters diameter. More than 10 to the 7th?
it was the Earth.
Earth is 10 to the 7th.
Like 10 to the
So 10 to the, well, no, the sun pretty much dwarfs us. Maybe 10 to the 10th meters?
Let's say 6 times to the left, 5 times 10 to the line. Let's go 10 to the
Well, if we went 10 to the 10th, what's the diameter of a human blood cell? So a typical cell is, what, measured in nanometers? No. Micrometers, right? So 10 to the negative 6th. So,
Yeah.
okay, so let me give you a few. So let's say 10 to the negative 6th. What would that give us for the order of magnitude of those things divided? 10 to the 16th. So let's submit an answer. The Fermi website says 10 to the 14th is the correct order of magnitude. Okay, we'll stop the notes there for today, but I'm going to still discuss. I'm just going to stop the